Hello, my dear mechanical and civil champions. How are you all? What's up? कैसे हैं सब लोग? Please guys do join me fast. And those who are watching me live, please respond through the comment section so that we can start our beautiful session on time. जैसा कि आप देख पा रहे हैं on the screen, we are here to discuss the wonderful numericals, to solve the numericals. Actually, you should solve the numericals in today's session so that you will be able to improve your fundamentals, concepts, and you will be able to understand the application part of the concept. Please guys do let me know through the comment section, those who are watching me live, if I am audible and visible to everyone. Namaskar, Adab, Shubh Sandhya, good evening, Sat Sri Akal, Assalamu Alaikum. कैसे हैं सब लोग? How was your Sunday? And did you guys revise the concept of fluid properties? If anybody is having any doubt, anything to ask, please do let me know through the comment section. Yes. Hi Susuban, good evening, welcome to the session. Please do keep on talking to me through the comment section so that I also get motivated, charged up to have this beautiful session with my full enthusiasm and full effort. Because the numerical practice is again very important and integral part of your preparation journey. Without solving the numericals, your preparation is not complete, and that is why we have started this series, pre-series on BYJU'S YouTube channel for GATE 23 aspirants, where we will be giving you the understanding of the concept, important concept of the subject, along with giving you the numerical practice session also, and there will be live quizzes as well to check your understanding for improving yourself further and further. Hi Shriya, welcome, good evening, namaskar. Good evening guys, welcome to the session. Please keep your pen, paper and calculator handy because you are going to solve the numericals. Don't be afraid of committing mistakes. Even if you commit the mistake, you will get the learning. The learning is never done without committing mistakes, without getting the errors or without getting the failure. So never be afraid of committing mistake. Raghavendra, welcome. Please keep on writing in the comment section, keep on talking to me so that we can start our session. So every alternate day, Monday, Wednesday, Friday and Sunday at 8 p.m, I am discussing the important concepts of fluid mechanics, and this is my entire schedule for this series. This is the entire schedule of fluid mechanics. You can take the screenshot and please be available every alternate day at 8 p.m. Keep yourself available for these free sessions which are going to help you a lot in your examination. All right. Shall we start? Ready? Please make some noise so that we can start our session. Any working professional over here? Before I start, let me quickly introduce myself. Most of the students already know about me. I am a mechanical engineering graduate from IIT Delhi, having more than 9 years of teaching experience in GATE, IES and PSUs, and I am quite comfortable in these many subjects of mechanical engineering. Fluid mechanics is one of my favorite subjects, which is common for mechanical and civil aspirants, and that is why this session is very important for not only for mechanical engineers but also for civil aspirants. So please share this session to all of your friends who are mechanical and civil engineers who are preparing for GATE 2023 examination. And you can always contact me. You can connect with me through the mail ID which is there on the screen, and you can join me on the Telegram group as well, which is Mechanical by Chandra Shekhar Sir, and the link is mentioned on the screen. So are you all ready to explore? the concept of fluid properties. In the last session, we had the theoretical discussion, and today we will be having the numerical practice session. All right. And there are paid courses also running on BYJU'S platform. You can be part of our paid classes to improve your performance in your GATE examination. We have proved our quality by giving the best possible results in GATE 2022. So you can always join us through the paid courses as well. And if you are not in the position to join our paid courses, you can get benefited through the free sessions which we take from time to time for all the engineering aspirants for GATE 2023. Hi Devabrat, good evening, welcome. Arun, welcome to the session. And if you have not liked the session yet, it is my humble request to everyone to like the session so that we can start and we can enjoy and we can get benefited from this session completely on numericals based on fluid properties. चलिए start करें. Do not forget to subscribe our YouTube channel so that you will get all the notifications and updates of our free sessions which we take from time to time for GATE and ESE aspirants. Yes, ready for the roller coaster ride. Shall we start? Please make some noise if you are all ready. First of all, I will discuss the assignment question. How many of you have tried the assignment question which was given in the last class? Did you guys try the assignment question? This is our assignment question. What is the answer? Please let me know the answer to this question. The homework questions are very, very important because they will give you the understanding of how to apply the concept. Even though the assignment question will be having the difficulty level quite higher compared to your GATE examination sometimes, but even if you are not getting the right answer, but it will give you the understanding of the thought process. You will be able to develop the thought process to apply the concept. I told you in the last class, in previous classes, that understanding the concept is one thing, but applying those concepts, how to apply those concepts definitely require more effort, more practice. The practice is the only solution to application, to get the application part better. Yes, what is the unit of this? The answer to the question, let me first of all give you the answer. 0.688 into 10 to the power minus 6 Newton meter or joule. That is the answer to the question. 0.688 into 10 to the power minus 6. Right? How many of you are getting the answer? जिन लोगों ने ट्राई नहीं किया है वो फिर से ट्राई करना. बट अभी मैं इसको सॉल्व करता हूं. The question will be solved in 3 steps. First of all, you need to understand the spherical water drop. Why the water drop is spherical? Why a water drop is spherical? Because of surface tension. The surface tension always minimizes the surface area of a liquid. I have told you the surface tension is the strong cohesive force between the interface molecules, and that is why, because of the strong cohesive force between the interface molecules, which is developed due to the net downward cohesive force, and that is why, because of the surface tension, the surface area of a liquid becomes minimum, and the minimum area is of sphere. That is why the shape of the water drop is spherical. It is required to split into 64 small drops of equal size. What is the work done? So I told you another definition of surface tension, that is the amount of work required to increase the unit surface area of the liquid. That is the definition of the surface tension. The unit is joule per meter square or Newton per meter. Sigma can also be defined as the amount of work required to increase the unit surface area of the liquid. Now, first of all, we will find out the radius of the smaller drop first. The volume of the bigger drop will be equal to volume of the smaller drops, 64 smaller drops. What is the volume of the bigger drop? 4 by 3 pi r cube, r is the radius of the bigger drop, is equal to volume will remain constant. Why? Because we are neither adding any water nor removing any water. So because there are 64 drops, 4 by 3 pi, small r is the radius of the smaller droplet. So by equating these two, we can say radius of the smaller drop will be equal to capital R by 4. That is the first step to get the radius. Yes, अथर्व, क्या बोला आपने? कुछ बोला आपने? The first step is equating the volume. Now, the second step is to find out the change in surface area. What is the surface area of the bigger drop? That is 4 pi into capital R square. What is the surface area of the smaller drops? The surface area, because the shape is spherical, there are 64 droplets, 4 pi small r square. So we can say 64 into 4 pi, it is r square by 16, isn't it? Small r can be replaced by capital R by 4. So if you solve this, so this will be surface area 2 will be equal to 16 pi capital R square. This is the surface area. So what is the change in surface area? Change in surface area is surface area 2 minus surface area 1, isn't it? That is 16 pi R square minus 4 pi R square. That is equal to 12 pi capital R square. That is the change in surface area. That is the second step. And the third step is to apply the definition of surface tension, that is the work done per unit change in surface area. So from here we can find out the work required to be sigma into change in surface area. Put the value, then work will be equal to, now it is time to put the value and get the calculation. Sigma is 0.073 into 12 into pi into capital R is equal to 0.5 mm into 10 to the power minus 3 meter whole square, isn't it? That will give you the required answer. Is this clear? Anybody is having any doubt, anything to ask, you just let me know. The radius will be, most of the students commit mistake here as well. It is 1 mm diameter. Diameter is 1 mm. So the radius will be equal to 0.5 mm. That is 0.5 into 10 to the power minus 3. I hope it is clear to everyone. Please make some noise. Do let me know if it is clear so that we can proceed further. बताइए jaldi jaldi. I am waiting for your response. The answer will be 0.688 into 10 to the power minus 6 Newton meter or joule. If you will put all the parameter in their SI unit, then you will definitely get the unit of work to be joule or Newton meter. Yes. Now it is time for you to apply your understanding. There is a question on the screen. The first question on the screen. Please solve this question. Very simple and warm-up question. I want everyone to get the right answer to the question. Now, one important thing. If you were part of my last session, I told you that density does not always mean the mass density. The word density can be mass density, rho, it can be weight density, gamma, or it can be relative density, that is S, depending on the unit. Similarly, the viscosity does not always mean that dynamic viscosity. It can be kinematic viscosity also. So the word viscosity does not always mean the dynamic viscosity. It all is decided by the unit of that parameter. If the unit is Pascal second, Newton second per meter square, or kilogram per meter second, or dyne second per centimeter square, or gram per centimeter second, or poise, then it is dynamic viscosity. If you remember the unit of dynamic viscosity, it is Pascal second or Newton second per meter square or kg per meter second. These are SI or MKS unit of dynamic viscosity. and CGS unit is dyne second per centimeter square or gram per centimeter second or poise. And you should be able to know the conversion. This is coefficient of viscosity, dynamic viscosity, or we can also call it as absolute viscosity. Why do we call it as absolute viscosity? It is called as absolute viscosity because it is not a function of density. Similarly, then there is another viscosity which is kinematic viscosity. SI unit is meter square per second and CGS unit is centimeter square per second or stop. You should be able to convert these. What is the answer? Yes. Is it A, Varun? Is it A or C? Acha, 0.025. Yes, it is option C. It is option C. C is the right answer. Very simple question. Now you can see stop is given. It means it is kinematic viscosity. What will be its viscosity in Newton second per meter square? It means dynamic viscosity is asked, and the relation between kinematic viscosity and dynamic viscosity is mu by rho. So dynamic viscosity is rho into kinematic viscosity. What is the density? Specific gravity is given as 0.9. So 900 is the density and kinematic viscosity is 0.28 into 10 to the power minus 4. Then you will get Newton second per meter square. Option C is the correct answer. Yes. So Subhan, Shubham, well done. Midun, Varun, Setupati, good. Keep it up, guys. Now the next question. Let us move to the next one. Very simple question. Quickly, let me know your answer. अगला क्वेश्चन आपकी स्क्रीन पे फॉर 1 करोड़ सिंपल है. To improve your confidence, the question is designed. Yes, Setupati, good. Setupati had given the answer A. What about others? Quickly. Very nice, Susoban. Good. I told you in the last class that Newton's law of viscosity is very important concept. Whenever you will have a numerical from the viscosity, it will always be solved by using Newton's law of viscosity. And what is the expression for Newton's law of viscosity? Newton's law of viscosity relates shear stress and rate of angular deformation or velocity gradient. That is the mathematical expression. According to Newton's experimental observation, he had said the shear stress developed in the fluid is directly proportional to either rate of angular deformation or velocity gradient, because rate of angular deformation is same as velocity gradient. That is why deformation and flow are same in case of fluid or velocity gradient. I have not received the correct answer. No, it does not relate. Newton's law of viscosity does not relate the velocity gradient and rate of shear strain. Rate of shear strain is d theta by dt. Velocity gradient is du by dy. It relates the shear stress and rate of angular deformation. Sorry to say, but Varun, Susoban, Setupati, Mithun, Shubham, everyone had given the incorrect answer to this question. समझ में आई अपनी गलती? It relates rate of shear deformation and shear stress. Yes, that is how the questions will have the twist. तो जल्दबाजी में definitely आप mistake कर बैठेंगे. Is this clear? It is option B, not option A. The correct answer is option B. Can we move to the next one? The next question, very simple but numerical. The next question, please do solve it again from the viscosity, or will be solved by the Newton's law of viscosity. But you should have the proper understanding of the unit. How to convert poise into Pascal second. That is also very important. 1 poise is equal to 0.1 Pascal second. What is the answer to this? The shear stress developed in a lubricating oil of viscosity. It is the dynamic viscosity because it is given as poise. The unit is given as poise. That is why it is the dynamic viscosity, that is 98.1 poise. Can we say 9.81 Pascal second, isn't it? If we multiply with 0.1, filled between two parallel plates 1 centimeter apart. There are two parallel plates which are 1 centimeter apart. There are two parallel plates which are 1 centimeter apart. So the thickness of the fluid will be, the thickness of the fluid is the distance between the parallel plates. That is H is equal to 1 centimeter or 1 into 10 to the power minus 2 meter. Then what? And moving with the relative velocity of 2 meter per second, because the velocity profile is not given. Because the velocity profile is not given, so we can assume the velocity profile to be linear. There is a fixed plate, and with respect to the fixed plate, another plate is moving, and the thickness of the fluid is h. We can assume the velocity profile to be linear in the fluid. So the modified expression for Newton's law of viscosity can be written as mu into V by h for linear velocity profile in the fluid. I had discussed this thing. So just put the values. V is the velocity of the moving surface with respect to the fixed surface. What is the correct answer? 9.81 into V, relative velocity of 2 meter per second, by 1 into 10 to the power minus 2, and that will give you Newton per meter square or Pascal. The correct answer will be 19.62, isn't it? By 10. Is it 9.81 into 2 by 10? The 1 centimeter. Is this clear? How much we are getting? Are we getting option B? Is it 19.62? There is a problem, isn't it? Into 2. Now, mu into V by H. Mu is 9.81. Mu is 9.81 into 2. 2 is the velocity upon. Yes, it is not correct actually. Now, B is not correct answer. B is not the right answer. So it will be 19.62 into 10 to the power 2 Newton per meter square, isn't it? So 1962 Newton per meter square should have been the answer. Yes. The options are incorrect. Either the options are incorrect or the unit of the given parameter might be incorrect. 1962 will be the right answer. 1962 will be the right answer. Alright. Let us move to the next one. Question number 4. Now solve the next one. Yes, Susoban. कहीं ना कहीं क्वेश्चन में कुछ मिस्टेक थी, इसलिए बी आंसर नहीं आ रहा. अदरवाइज द आंसर वुड हैव बीन बी. ये 9.81 marks to all. Yes. Yes, the next question, question number 4 on the screen. Please try to solve the next one. Question number 4. The equation of the velocity distribution over a plate is given by, there is a velocity profile given. If the velocity profile is given which is non-linear, then we are supposed to use the original expression for Newton's law of viscosity, that is mu into du by dy. Velocity gradient can be calculated by differentiation of the velocity profile. Use the velocity in meter per second at a point y meter from the plate measured perpendicularly. Assuming the viscosity is 8.6 poise, again the unit is poise, the shear stress at a point 15 centimeter from the boundary is. So it is 0.86 into what is du by dy, that is 2 minus 2y. Put the value of y, that is 0.86 into 2 minus 2 into 0.15 Newton per meter square. What is the answer? The answer to the question is option B. Again, very simple question. B is the correct answer. Right? अगला क्वेश्चन करिए. अगला क्वेश्चन आप सॉल्व करके बताएंगे. The next one. A 40 centimeter cubical block. There is a cubical block which is slide on oil. Viscosity is given over a large plane horizontal surface like this. This is how it is sliding over a horizontal surface. The cubical block is sliding over the horizontal surface, and the gap between the block and the plate is containing the oil of viscosity 0.8 pascal second. If the oil film between the block and the surface has a uniform thickness of 0.4 mm, what will be the force required to drag the block at 4 meter per second? Ignore the end effect and treat the flow as two-dimensional. What is the answer to this question? Everyone, इसको solve करिए और बताइए. There is a flat surface and the block is moving, cubical block is moving like this. With a velocity of 4 meter per second, and the gap is filled with oil having the thickness 0.4 millimeter. Unit are very, very important. Now, because the velocity profile is not given in the fluid, we can assume the linear velocity profile. So, tau can be written as tangential force per unit shear area, which is mu into V by H. Our objective is to find out the force required. This is the tangential force for the fluid. This force will be the tangential force for the fluid. For the fluid, it will be the tangential force. The force acting on the block will act as a tangential force or the shear force for the fluid, parallel to the fluid, because it is acting parallel to the fluid. And what is the shear area? The contact area of the moving surface and the fluid. The dimension of the cubical block is 40 centimeter. Do you agree this is the shear area? 40 into 40 centimeter square. So that will be the contact area. So the tangential force we are getting as mu is 0.8 pascal second into shear area, that is 0.4 into 0.4 meter square. This will be the shear area, contact area between the moving surface and the fluid, 40 by 40 centimeter square. So 0.4 into 0.4 meter square into V. V is the tangential velocity of the fluid particle in contact with the moving surface, that is equal to 4 meter per second due to no slip condition, divide by the thickness of the fluid H, which is 0.4 into 10 to the power minus 3. If we will put all the parameter in their SI unit, then you will get the answer in Newton. Yes, Thomas, very nice. The correct answer. Are you getting? Now it is time for you to solve. What is the answer? Shear stress is shear force per unit shear area. Thomas, yes. Shear stress is shear force per unit shear area. You need to understand the shear force is the force which acts tangential or parallel to the surface of the fluid surface. And the shear area is the contact area of the moving surface and the fluid. So you will get option A as the correct answer. I hope it is clear to everyone. Now, the next question is for you guys to solve. अगला क्वेश्चन आप सॉल्व करके बताएंगे. Try to apply the concept of Newton's law of viscosity and get your answer. It is quite similar to earlier question. The only thing is now the surface is inclined over which the cubical block is sliding. Now the surface is inclined, making an angle 30 degree with the horizontal. Now what will be the changes? And again the gap between the inclined plane and the block is lubricated with oil of viscosity 0.1 poise. Then the thickness of the fluid layer is. What is the answer? तो सोबान इस क्वेश्चन का आंसर है या पिछले क्वेश्चन का आंसर है? Can you guys give it a try? Now this is the block. The weight of the block always acts in downward direction. The weight of the block, which is equal to m into g, will be acting into downward direction. And if we resolve this into two components, one is normal to the inclined surface and another is parallel to the inclined surface. So we can say if this angle is 30 degree, this angle will also be 30 degree. So this is mg cos 30 and this is the tangential force for the fluid. The tangential force will be m into g into sine 30. That is the catch here. The tangential force for the fluid is the force which is acting parallel to the fluid. The tangential force for the fluid is the force which is acting parallel to the fluid. So it is not weight. Weight always acts in downward direction. It is the component of weight, sine component of weight, which will act as a tangential force. And the area will be the contact area. Everything else will be same. So tau is equal to tangential force per unit shear area, which is equal to mu into V by H. The question is to find out H. So we can say H will be equal to mu A V by the tangential force. The viscosity is 0.1 poise, so 0.01 Pascal second into area is 2 meter is the side, so 2 into 2 is the area. V is 10 meter per second. Divide by m, that is 20 kg into g, that is 10. Sine 30 is 1 by 2. If you will put, then you will get your answer in meter and then you will get your answer in, you can find the answer in millimeter. Yes, everyone please do let me know your answer. Have you understood it? The tangential component of weight or the sine component of weight will be the tangential force for the fluid. That is how you need to apply the Newton's law of viscosity by having the understanding of the physical significance of each and every parameter which are used in the Newton's law of viscosity. Option A. Are you getting option A or not? Please do let me know if you are getting option A. And even if you are not getting option A, do let me know. I hope it is clear. The next one. The next question. Now, a piston weighing 9.42 Newton, the weight of the piston is 9.42 Newton, of 800 mm diameter and 200 mm long, moves inside a cylinder of 804 mm diameter. There is a piston. This is the piston. And there is an outer cylinder like this. Piston and cylinder arrangement. The outer cylinder is fixed. The gap is filled with some lubricating oil. The gap is filled. The diameter of the piston is, let us say, small d. And the diameter of the cylinder is, let us say, capital D. So D is equal to 800 mm and capital D is equal to 200 mm. Sorry, 804 mm. And the length is 200 mm. Length is equal to 200 mm. Now the space is filled by a lubricating oil. Now the question will be solved from the Newton's law of viscosity. Tau is equal to tangential force per unit shear area is equal to mu into V by H. Why we are using the linear? Because the velocity profile is not given. We are using the linear velocity profile and applying du by dy we are writing as v by h. That is constant. That is constant for linear velocity profile, because the velocity profile is not given in the fluid. Now, what is v? V is the tangential velocity of the fluid particle in contact with the moving piston. The tangential velocity of the fluid particle in contact with the moving surface. So that will be same as the velocity of the piston. That is to be calculated. So if we are getting the velocity, tangential velocity of the fluid particle in contact with the piston, we will get the velocity of the piston because of no slip condition. What is h? What is the thickness of the fluid? The thickness of the fluid is the distance between the fixed and the moving surface. What is the thickness of the fluid? Here also people commit mistake. H is not equal to d minus d. It is d minus d by 2. The thickness of the fluid is the gap between the piston and the outer cylinder. That is equal to 2 mm is the value of H. H will be 2 mm. H will be 2 mm. H will not be 4 mm. Try to understand. There is a cylindrical piston and there is outer cylinder which is fixed. The gap is the fluid thickness is the gap between the piston surface and the cylinder surface. That is capital D minus small d by 2. 2 mm is the thickness of the fluid. And what is the shear area? The shear area is the contact area of the piston with the fluid. This is the shear area in this case. The shear area, because there is a piston and there is a fluid on the periphery of the piston. There is a fluid, lubricating oil is on the periphery. So the shear area is the contact area of the piston and the fluid. That is pi dl. Are you understanding it? Contact area is pi into small d into L. That is the area. And what is the tangential force? Now again try to understand. The fluid is in contact with the piston like this. And piston is moving because of its own weight. The piston is moving because of its own weight, and the weight of the piston will act as a shear force to the fluid. In this arrangement, the weight of the piston is acting as the shear force or the tangential force to the fluid. So Ft will be equal to weight of the piston. Are you getting it? The only unknown in the question is the velocity of the moving surface. Can you find out the value of V? So V is equal to Ft into H upon A into mu, isn't it? Ft into H upon A into mu. Put the values, you will get the answer. Tangential force is 9.42. The fluid thickness is 2 into 10 to the power minus 3. Divided by area will be equal to pi into D, that is 800 mm, that is 0.8 into 0.2 into mu. What is the viscosity? Viscosity is given as 5 centipoise. You need to convert it into poise. 5 into 10 to the power minus 2 poise, and then multiply with 10 to the power minus 1 to get it Pascal second. Centipoise can be converted. 1 centipoise is equal to 10 to the power minus 2 poise. I hope you will be able to get the answer. What is the correct answer? B. Put the values and try to solve this. This 10 to the power minus 3 will get cancelled out with this. If you will put all the parameter in their SI unit, then you will get the unknown in its SI unit, isn't it? Are you getting 7.5 meter per second or not? If anybody is having any doubt, you can just let me know. Otherwise, let us move to the next question. बताइए, कोई किसी को कोई confusion? You should be able to understand the physical meaning of each and every parameter used in the Newton's law of viscosity. That's it. Ketupati, how you are getting 6.5? It is 7.5 meter per second. The next question, theoretical question, conceptual question. Now I want you to solve the next one. Give me the answer to the next question. Question number 8. There are 12 questions in total. Or those who are not able to solve these questions at the first place, please do try to solve them later on. After the class, you just give it a try, give these questions a try. The more you try independently, the more confidence you build. So try to solve these questions independently, and if you are stuck in the concept, read the related concept from the reference book or from the notes. I hope you have already arranged the notes for the fluid mechanics. If you have not, you can join me on the Telegram. We will share the notes of our classroom course. What is the correct answer? The statement first is, in general, viscosity in liquid increases and in gas it decreases with temperature. The statement 1 is incorrect. So as the temperature increases, viscosity of liquid decreases and viscosity of gas will increase. It is opposite. And is the reason correct? The viscosity is caused by intermolecular force of cohesion, cohesive force, and the molecular momentum transfer between the fluid layer, of which in liquid the cohesion dominates and in gas the molecular momentum contributes the major part towards viscosity. Yes, that is true. Reason is true. The reason is true, but the assertion is not correct. Are you getting it? So option D is the correct answer. D is the right answer. The next question. The next one, from the units and dimensions. Get me your answer to the next question. Dynamic viscosity, that is mu, that is kg per meter second. M1 L minus 1 T minus 1, that is A3. Chase's roughness coefficient, you might not be knowing about Chase's roughness coefficient. Bulk modulus of elasticity is unit of Pascal. The bulk modulus is Pascal. Pascal means Newton per meter square. Newton per meter square is kg meter per second square multiplied by 1 by meter square. So meter getting cancelled out. So it is kg per meter second square. That is Pascal. Or M1 L minus 1 T minus 2. M1 L minus 1 T minus 2. So C is 2. C2. Surface tension Newton per meter. M1 L0 T minus 2. Newton per meter. Surface tension Newton per meter. Newton is kg meter per second square upon 1 by meter into 1 by meter. So kg per second square, M1 T minus 2. So D is 1. D is 1. And what is Chase's roughness coefficient? Chase's roughness coefficient is given by under root 8 G by F. That is Chase's roughness coefficient. So it is having the unit under root of meter per second square. It is L to the power 1 by 2 into T to the power minus 1. That is the unit. 4. 3, 4, 2, 1. The correct answer is 3, 4, 2, 1. Option C is the right answer. Yes. So you should be able to have the understanding, or you should be able to apply the understanding of units and dimension as well. Very, very simple question. Next question. Question number 10 is very, very simple. Everyone, please give me the answer for question number 10. Quickly. सिविल वाले पढ़ते हैं. Chase's roughness coefficient सिविल वाले पढ़ते हैं, तो सिविल वालों को पता होगा definitely. What is the answer to question number 10? Memory based. Do you remember, for a surface, this is D1, this is D2, delta P into D1 into D2 is equal to sigma into 2D1 plus D2. This is the expression, that is the pressure force which is normal and compressive, that is the surface tension force which is normal and tensile. So from here we can say delta P is equal to divide by d1 into d2, so it will be sigma into 2 by d1 plus 2 by d2. And for a liquid droplet of water, d1 is equal to d2 is equal to d. So it will be 4 sigma by d, isn't it? B is the correct answer. Question number 11. Question number 11 on your screen. Yes, Thomas, that is the art of, Thomas is saying by using the process of elimination also we can get the answer. That is the art that you need to understand. Art of getting the correct answer. Even if you do not know the understanding of each and every parameter in the question, but by eliminating, by using the negative approach, eliminating approach also, you can get the correct answer. Or by using the concept of unit and dimension also, sometimes you can get the correct answer to so many questions. That you need to learn the art of clearing any competitive examination. That is an art. Yes. For a soap bubble, there are two interfaces. For a soap bubble, there are two interfaces. There is air inside. There is a liquid here. There is air outside. So there are two interfaces. Air liquid interface and then again air liquid interface. So that is why delta P, that is inside pressure minus outside pressure, is given by 8 sigma by D. It is twice. The question is the pressure inside a soap bubble of 50 mm diameter. Diameter is 50 mm. Thickness is negligible. That is why D1 is equal to D2. Is 25 Newton per meter square. This is 25 is equal to 8 into sigma by diameter is 50 mm, that is 0.05. Put the value, you will get sigma. What is the answer? It is 8 sigma by D. So sigma will be equal to 25 into 0.05 by 8. What is the answer? (0.156) ऑप्शन ए. बी क्यों आ रहा है? ऑप्शन ए 0.156. And the last question for today, I want you to give me the correct answer for this question. The last one. And we are going to meet again tomorrow only, Monday, and we will talk about the manometry, very important and very beautiful topic of fluid mechanics, very interesting topic of fluid mechanics, that is manometry. That is about the pressure. Very important and interesting topic. Please do join me tomorrow at 8 p.m. Tomorrow at 8 p.m. on the same platform. What is the correct answer? Air bubble is not equal to soap bubble. They are not same. Air bubble is very much similar to liquid drop. Air bubble, you can see this is the air bubble. This is the air bubble. Outside there is a liquid, inside there is an air. Only one interface. Yes, Thomas. We will discuss about the various manometers as well. So that is why the concept will be, the formula will be applied as 4 sigma by D. It will not be 8 sigma by D. It will be 4 sigma by D. And that is why your answer should be 288. 4 into 0.072 upon diameter, that is 1 mm, that is 1 into 10 to the power minus 3. It will be 4 sigma by D. That is how the questions are framed. If you are able to understand the basic concept, then you will be able to apply the correct formula. 288 will be the answer. And now it is time for the homework question. Take the screenshot of this homework question and do share your answer on my Telegram group. Or you can share your answer in the comment section as well. Yes, Deepak, there is no difference between an air bubble and a water drop. The only difference is in water droplet, water is inside, air is outside. But in air bubble, air is inside and water is outside. Both are having the spherical shape due to surface tension. All right. There is the question on the screen, though the question is a little bit on the tougher side, but that will give you the understanding of the how to apply the concept of Newton's law of viscosity, how the questions can be framed based on Newton's law of viscosity, which are more on the tougher side. All right, do give it a try, because मैंने आपको पहले भी बताया है, learning is never done without committing mistake, without committing any errors. With this note, keep on trying, keep on learning. With this note, let me take your leave. Enjoy, have a good day, and do not ever stop learning, because learning is a continuous process. Be like fluid, be like water. Water never gets tired of flowing. Deepak, statics के बाद kinematics. Tomorrow and day after tomorrow and the next class will be dedicated to statics. Then we will move to the kinematics and then dynamics. Yes. So guys, let me take your leave. Enjoy, take care, have a good night. Sabba khair, take care, stay safe and stay motivated. Jai Hind.